In this video, we will solve quadratic equations by factoring. What do we mean by a quadratic equation? A quadratic equation in one variable x is an equation that can be written in the form ax squared plus bx plus c equals 0, where a, b, and c are fixed real numbers and a is non-zero. A quadratic equation in this form is said to be written in standard form. Note that a quadratic equation is one that can be written in this form. It may appear in other forms. Let's consider a variety of examples. Notice that in each example equation there is a variable x that would appear to the second power if the equation was put in standard form. However, not all of these equations are currently written in standard form, but each constitutes what we call a quadratic equation. There are 4 algebraic methods for solving quadratic equations in one variable. The most basic method is called factoring and will be the topic of this video. Other videos discuss the other 3 methods. The second method is called extracting square roots. It is essentially a shortcut for one particular factoring technique. The third technique, completing the square, is a generalization of the second method. And the fourth method, using the quadratic formula, uses a formula derived from completing the square in general. The factoring method for solving quadratic equations uses the zero product theorem. This theorem says if a product equals 0, then at least one of its factors must be 0. Let's use this theorem to solve the equation x squared minus 5x minus 6 equals 0. We notice that the equation is already written in standard form. However, in this form, we have a sum equaling 0, which is not particularly helpful. If we factor the quadratic x squared minus 5x minus 6, as the product x minus 6 times x plus 1, then we have a product equaling 0. The zero product theorem guarantees that one of the factors must equal 0. So now we have 2 linear equations to solve. Thus, x equals 6 or x equal -1. Let's consider another example. Let's solve the equation quantity 2/3 x minus 1 times the quantity x minus 1/5 equals 0. This is a quadratic equation that is not in standard form. However, we do have a product equaling 0, so we can apply the zero product theorem directly. We set each factor equal to 0 and solve the resulting linear equations. We add 1 to both sides of the first equation and add 1/5 to both sides of the second equation. Finally, we multiply both sides of the first equation by 3/2, and we get that x equals 3/2 or x equals 1/5. For our third example, solve the equation x squared plus 7x equals 0. This time we have a quadratic equation, it is in standard form, and the constant term is 0. It would be useful to have a product equaling 0. Factoring x squared plus 7 as x times x plus 7 gives us a product equals 0. We set each factor equal to 0 and solve for x equals 0 or x equal -7. Now let's consider quadratic equations that are not in standard form. Solve the equation 4x squared equals 25. Although this problem looks different from our previous examples, we can make it look familiar by putting the quadratic in standard form. We subtract 25 from both sides, and now the left-hand side is a difference of squares. We can factor 4x squared minus 25 as 2x minus 5 times the quantity 2x plus 5, and we have a product equaling 0. Using the zero product theorem, we set each factor equal to 0 and solve the resulting equations for x. We get that x is 5 halves or x is minus 5 halves. Let's consider one last example. Solve the equation quantity x plus 3 times the quantity 2x minus 1 equal 9. This is a quadratic equation, although it is not in standard form. Also, we have a product, but the product equals 9. There is no theorem for a product equaling 9 because there are infinitely many ways to multiply two numbers and get 9. Let's try expanding the product and putting the quadratic in standard form. First, we multiply x plus 3 times 2x minus 1 to get 2x squared plus 5x minus 3 equals 9. Then subtract 9 from both sides to get the quadratic equation in standard form. We can factor 2x squared plus 5x minus 12 as the product of the quantity 2x minus 3 times the quantity x plus 4. Now we have a product equaling 0. We set each factor equal to 0 and solve the resulting equations for x equal 3 halves or x equal negative 4.